Nodal analysis. In general, if the network consisting of n nodes, one of the node is chosen as a reference node, then it is possible to write n-1 nodal equations by assuming n-1 node voltages. For example, in the given circuit, we have three nodes, 1, 2, and this is a third node. So total number of nodes in this circuit is 3. The 3 node is taken as a reference node. In -1 nodal equations we are going to get. The node voltage is the voltage of a given node with respect to one particular node called reference node, which we assume at zero potential. To apply the nodal analysis, the voltage at node 1 is the voltage at the node with respect to node 3. We'll consider this as V1. Node 2 will consider this as V2. The current is coming from here and leaving here at this node. Similarly, when you consider node 2, this is the current direction. Since whenever we consider a node, the node will be at higher potential. Here we are considering a node 1. So node 1 is at higher potential than other voltages. Then applying KCL at this node, we are going to get the current I1 is coming equals to the current which is leaving, that is voltage divided by the R1, plus the current leaving this node, that is V1 minus node 2 is having the potential of V2. So V2 divided by R2. Now, if you simplify this, you are going to get 1 by R1 plus 1 by R2 of V1 minus 1 by R2 of V2, which equals to I1. Now, at node 2, applying KCL again here, then you are going to get current in this node is leaving, the current in this node is also leaving, current in this node is also leaving. So first this branch, that is V2 minus V1, will be having here R2, so divided by R2 plus V2 by R3 plus V2 by the total resistance, that is R4 plus R5, which equals to 0 since there is no current source. If you simplify this, you are going to get V1 of minus 1 by R2 plus V2 of 1 by R2 plus 1 by R3 plus 1 by R4 plus R5, which equals to 0. Now, by solving these two equations, number 1 and 2, we are going to get the node voltages V1 and V2. So, nodal equations by inspection method. So, consider the same network. We'll be having three nodes. This is my node 1 having the voltage potential V1, node 2 is having voltage potential V2, whereas a third node is considered as a zero potential or a reference node. This is the current coming to here, so this is I1, whereas this is the current is going through this is IR1, let it be, and this is the current flowing through this is IR2. Similarly, for this node, this is IR3 and this is IR4. The nodal equations for general planar network can also be written by inspection without going through the detailed steps. Now, at node 1, applying KCL, node 1, the I1 is coming to the node, so I1 equals to IR1 plus IR2. The voltage in between the node 1 and the reference node is V1 divided by the resistance in this branch, that is R1, plus IR2 is the current through this branch, that is nothing but the voltage differences between these two branches, that is V1 minus V2 divided by the resistance, that is R2. Now if you rearrange this, you are going to get 1 by R1 plus 1 by R2 of V1 plus V2 of minus 1 by R2 is equal to I1. This is in the form of I1 equals to, this is sum of the conductances of the node 1 multiplied by the voltage V1 plus This is sum of the mutual conductance. Since we have only one resistor here, we are considering this as one conductance. If we connect one more conductor here, then we are going to get sum of the conductances. V2. Similarly, at node 2, applying KCL, I R2 is coming to this equals to I R3 plus I R4. So I R2, we know that V1 minus V2 divided by R2, which equals to I R3, that is V2 by R3 plus I R4, that is V2 divided by R4 plus R5. Now if you rearrange this, then you are going to get minus 1 by R2 of V1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus R5 of V2 equals to 0. Now this is in the form of I2 equals to G21, sum of the mutual conductances between the 2 and 1 plus the sum of the conductances connected to the 2 itself of V2. Since source current is not connected to the node 2, we can't. I2 equals to 0. G11 here is sum of the conductances connected to node 1, whereas G12 is sum of mutual conductances connected to node 1. Here, and the second one, the G21 is the sum of mutual conductances connected to node 2. Similarly, G22 is the sum of conductances connected to node 2.